Here's a question that might keep you up at night. What if the smartest AI in the world can't solve a problem, not because it isn't smart enough, but because it was trained to find one right answer, instead of exploring many possibilities? That is the quiet crisis in AI post-training. And today, we have a fix that rewrites the rules of how we teach AI to think. Welcome to the intelligence revolution. And today, we're digesting the most striking finding from over 350 papers. The way we train AI after its initial learning is fundamentally changing. We're moving from find one perfect answer to discover a whole landscape of possibilities. We'll cover vector policy optimization, the new RL training paradigm. Then we'll look at a sandbox system that makes AI agents nearly immortal, and a medical knowledge graph that finally understands when things happen. Stay until the end because you're going to see how AI is learning to explore before it exploits. And that changes everything. Let's rewind. How do we train AI to solve hard problems? For the last few years, the dominant method has been reinforcement learning from human feedback, RLHF. You train a model to maximize a single reward score. It's like telling a student, get the highest grade possible on this one test, and it works for a while. But here's the problem. Real-world problems aren't single-score tests. They are multi-objective. A good code solution should be correct, efficient, readable, and secure. A good medical diagnosis should be accurate, timely, and cost-effective. When you collapse all these into one number, you force trade-offs that the AI can't navigate. This is the optimization trap. You optimize for one score, and you lose the richness of the problem. The AI becomes a specialist, not a generalist problem solver. And when you need it to adapt to new constraints, it fails. Enter vector policy optimization, VPO, from today's brief. RL post-training is now about diversity, not optimization. Instead of training an AI to maximize one reward, VPO trains it to produce diverse solutions that span the Pareto frontier of multiple reward components. Let me break that down. Imagine you're a chef. Traditional RL training says, make the best possible pizza. One pizza. Maximize that taste score. VPO says, here are 10 ingredients. Show me 50 different pizzas you can make, each one trading off cost, health, and taste differently. That's the Pareto frontier, the set of solutions where you can't improve one metric without hurting another. VPO trains the model to produce diverse outputs that span this frontier. Then, at test time, you search through these candidates to find exactly what you need. The key insight: separate exploration from exploitation. Train for diversity. Exploit at test time. The paper shows this works. On Live Code Bench, a notoriously hard coding benchmark, VPO-trained models unlock problems that GRPO, the current state-of-the-art, cannot solve at any candidate budget. Not solves more problems, but solves problems that were previously impossible. And because VPO is a drop-in replacement for GRPO Advantage Estimator, it's immediately practical. No new infrastructure, no retraining from scratch. But VPO isn't the only breakthrough today. Let's talk about making AI agents actually useful. Delta Box solves a problem that's been killing agent-based AI: checkpointing. When an AI agent explores a task, say, browsing the web to book a flight, it needs to try different paths. But each path requires saving the entire state of its sandboxed environment. Traditional checkpointing takes seconds. Do that thousands of times. Your research project just became a waiting game. Delta Box's insight: agent checkpoints are highly similar. So instead of copying everything, the entire file system, the whole memory, just copy the changes.